Now that we've seen the basic idea of creating a class and creating instances of a class, and we've seen the idea of defining methods for them, including methods that are sort of the built-in or associated methods, like what does it print like, how do I create an instance, let's look at how we would use this idea of a class. And probably the best way to do that is to simply take an example. So I'm going to create a new type of object to represent a number as a fraction, and literally as a fraction, not as the floating point equivalent of that. What do I need? I need to say, what's the internal representation? What are the data attributes I want to glue together, and how am I going to represent them? And then, what's the interface? Or if you like, the methods that I'm going to use to interact with instances of those fraction objects. In my case, for a fraction, I want a numerator and a denominator, a top part and a bottom part. In terms of the interaction, the interface, the methods, I certainly want a print representation so I don't get something messy coming out. But I'd like to think about simple things like, how do I add fractions? How do I subtract fractions? And one other thing I might like is, if I wanted to, how do I convert a fraction into an actual floating point number that I could then use standard Python arithmetic operations on? Let's see how we would build that. And what you're going to see here is less the details of doing fractions, more the idea of how I use the methods to define behaviors that I want to associate with different objects, in this case, fractions. Okay. So initially, I need to define the class of a fraction. I use class to say it's the definition of class. I've got the name. And as before, this is going to inherit from the underlying object class. I also need, as always, to define what does it mean to create one of these objects. So I've got an init method. It takes in two arguments besides self. That is a numerator and a denominator. And I'm just going to bind those locally within the frame associated with every instance of a class. I'm also going to define what I want to have printed out when I do this. And here I'm simply going to have it print out a string representation of the numerator and the denominator separated by a slash, sort of like you'd expect to see inside of a fraction. There's my definition initially of what a fraction looks like. Let's see what happens if I use that. So I'm going to go over to my machine, load this up, and let's do the two definitions. Let's give the name 1/2 to the fraction of 1 and 2. Let's give the name 2/3 to the fraction, obviously, of 2 and 3. And let's see if it prints out appropriately. So if I print out 1/2, yep, does what I'd like. And obviously you would expect 2/3 ought to do the same thing, but let's just check it. There we go. All right, so we can create fractions. We could create a bunch of them. Little boring. What could we do with fractions? Well, as I said, I'm going to do some operations on it, but before I do that, I want to introduce one more important idea. And that goes back to something we talked about earlier, which I'm going to pull in a second. And the new idea is to create something that lets me access data attributes. These are often called getters. I'm going to get out the elements of that. And here, I'm going to define a getter for numerator and a getter for denominator. I'm going to give them obvious names. I could give them anything, but I'm going to say getNumer should give me back the numerator of a fraction, and getDenom should give me back the value of the denominator of an instance of a fraction. Why am I creating those? Well, those are going to be important because it's going to separate out accessing the internal representation from the actual use of the representation. But let's check to make sure it does the right thing. You can see what I expect it to do, and if I say 1/2, and I use getNumer, that's great. It gives me back the numerator of 1/2. Notice the call. There's the dot, and I'm going to step through this carefully. 1/2 points to an instance. It's a frame somewhere. The dot says, get the binding for getNumer in that frame. Oh yeah, that was the definition that I did right back here of a method inside actually the frame of frame of fraction, but I inherit it because 1/2 is an instance of fraction. But the last piece is that simply gives me back the procedure. To make it run, I have to invoke it. And while it takes no arguments other than self, which is automatically provided, I need to say open close paren to actually invoke it. Do the same thing with getDenominator. I can get out the pieces of them. As we said, this is a procedure. I've got to invoke it. And remember again, self is provided separately for me. I can now use that to define things like how do I add fractions or how do I subtract fractions. And notice, while it looks a little messy at code, it actually is going to have an important property. So here's a definition of add. It takes two arguments, the instance itself and some other fraction. And inside of there, I'm just going to do the work to actually define what it means to add together two fractions. I take the numerator of one, the denominator of the other, multiply them together. I take the denominator of one, the numerator of the other, multiply them together. Add those up. That's the new numerator. The denominator is just the product of those two products. And if you're looking at the slide carefully, I notice I have some typos here. Ignore them. My method is actually going to do them correctly. That's snuck in somehow into my slide. Last piece of this is, having computed that numerator and denominator, I need to return an instance. And I create one by calling fraction with new values for the numerator and the denominator. Subtraction does the same kind of thing. Let's see what happens if I actually use that. So I've got those two versions there. Let's call new what I get by taking 1/2 and 2/3 and adding them together. And what does new look like? Perfect. Let's do one more example. Let's call 3/4 the obvious thing, the fraction of 3 and 4. Let's just make sure it works in other kinds of versions here. So I'm going to call second new. Well, actually, let's just print out 3/4. I can print it. And there it is. And if I let second new be, let's do 2/3 minus 3/4 because I define sub as well. It needs to type it properly. My apologies. Let's do it one more time. This is 2/3 minus 3/4. I can print that out. Great. Exactly what I'd expect. I've now got the ability to create new instances of fractions by doing arithmetic operations on them. And notice how plus and minus are overriding, if you like, the built-in versions of those. And I'm using that in order to be able to do this in a manner that lets me type things that make sense, but have things come out the right way. Last thing I said I wanted to do is to be able to convert fractions into floats. And that's easy. Convert would simply take the numerator by using the getter for that, take the denominator by using the getter for that, and just do division. And so if I ask, for example, to convert second new, I did that wrong, my apologies. I'm going to do second new dot convert. It prints out the floating point representation of those pieces. Great, it's exactly what I'd like to have. There are some examples of that, just like we did. This is something that's going to give us the ability now to think about elements of this class and simply use them. I'm going to do one more example, but before I do it, I want to say another word about those getters and setters. Why do I want to create separate getters and setters? Remember we said we don't want to directly manipulate the internal representation of an object. We'd like to separate the use of the object from what's inside of it. And those getters and setters nicely do that. It says anytime I want to access something inside an object, let me use the method that gets that part of the object out. I'm going to come back to that idea when we do our second example. And the second example is, suppose we wanted to build a little collection, a set of integers. Initially the set's empty, and I want to have the property of that set be that an integer appears only once inside the set. That's what we would call a representational invariant of this particular object. And I'm going to enforce that by the way I write the code. I don't want to have to go and check, did I have more than one instance inside the object? I want it to be the case that as I add elements to this set, I'm always making sure that there's never more than one particular version of that integer inside of that set. I need two pieces. Data representation, I'm just going to use a list to store the elements of the set. And I need an interface. How do I interact with this? And for that, I'm going to have the ability to insert an element, the ability to check if an element is there, and the ability to remove an element. And the description is exactly what you expect. Insert's going to put that element into the set if it's not already there. Member will tell me true if in fact an element's inside the set. And remove will take the element out of the set and complain if I try to take something out that wasn't already inside of the set. Again, a bunch of words. Let's do an example. Here's the definition of the integer set class. And I'm going to do this a little more quickly because you should be getting used to these pieces. I have something that creates instances. In this case, there's no argument to it other than self because it starts out as empty, and it's simply creating an internal binding for the variable vals, which is going to be my internal name for the set, to the empty list. I can insert things into the set, and here's where I'm going to enforce the representational invariant. I'm going to take advantage of the property of lists. So when I want to insert a particular element into an instance of an integer set, I'm going to first say, is that element inside the list? And I'm just using that iterable operation on lists to use that. If it isn't, I'm going to append it into the list. If it is, I'm simply going to skip by because there's nothing to do. I want to check if something's inside the list. Again, I can use the property of a list. I can simply say, return E in self.vals. That simply says if E is in that set, that list, it's going to be true, otherwise false. What else did I need? I need to be able to remove an element from a set. And here I'm going to use that nice property of exceptions. I'm going to try to simply remove directly something from a list. I'm using the property of lists here because vals is a list, remove is a method associated with lists, and it's going to try and remove the first instance, should be the only instance, the first instance of that variable E from that list. If, in fact, E was not in the list, it's going to raise an error. And the exception then is going to come down to here, and I'm going to raise my own particular error to say that particular element was not found. I'm going to override the underlying value error exception method. And finally, I'm going to use string to define how I want to print out the elements of a set. This is a little funky, but what I'm simply going to do is take vals, which is a list, and I'm going to sort it by using the sort method and call it. And notice I've got 3 dots here. Actually makes sense. It says self gives me the instance. Dot says look up vals inside of that instance, which is simply a binding. And then because vals is a list, the next dot, this one, says find the method sort associated with lists and then apply it by calling it right there. Once I've sorted it, I'm going to run through a little loop where I set result to be the empty string. And then for each element in the now sorted version of vals, I'm going to simply add it in together with a comma. And then when I'm ready to return it, I'm going to return a string that has a curly bracket on each end. And I got 1 extra comma hanging around at the end of the last element. So I'm going to take result and return everything but that last element to get rid of that last piece. And now let's try it out. I'll show you some examples here, but I actually want to go over and type them on the machine so you can see that it does what we would expect. So I'm going to define S to be an integer set. And I could print out what S is, and it just gives me the 2 curly braces. There's nothing there. Now, let's put some pieces inside of S. I'm going to insert 3 into S. I'm going to insert 4 into that set. I'm going to insert 3 again because I have a short memory and I've forgotten I've already done that. And I want to say, oh, wait a minute, what does S look like? Oh, that's nice. It's just got 1 version of 3 plus 4. I go back to what I said earlier. I'm going to enforce in my implementation that representational invariant, that an element appears only once. And if you look back at the code, you realize that second insert of 3 would have checked to see is 3 already in the internal representation. It is, so don't add it. What else could I do? Well, I could check to see if something's in the list. So I could say, is 3 in the set S? Yes, it is. Is 6 in the set S? No, it isn't. And that's great. Notice, by the way, on my machine, whenever I type one of those methods, it nicely brings up something that tells me what the doc string associated with it is, what it expects to do. What are the inputs it's expecting there? Things that are going to help us think about what do these different methods do. What else could I do? I can remove something. So I can go back to S and say, let's remove 3. Okay, and I did that fine. And let's get rid of, let's add in 6 to that. And if I look at what S now consists of, not surprisingly, I've taken out the 3, I've added in the 6. I'm simply using those built-in methods to manipulate that set. I could do one other thing here, and I'm not going to do it on my machine, but simply point out what will happen here If I try to remove an element that's not currently in that instance of the set, it's going to throw an error, and it's going to print out what I asked it to print out, which is different from the generic exception that I would raise, because I raised a specific version of value error that said, please print out the specific element and the string not found, telling me what it was that went wrong when I tried to do all of this. So there are two examples. Notice how we define an init method for each of them. We define a string method for each of them to tell us how we're going to print things out. And then I create methods specific to this kind of class that let me manipulate instances of that class.